hier an der Innovation Stage auf der EMO 2025 in Hannover. Schön, dass Sie da sind. Ich hoffe, Sie hatten eine fantastische Mittagspause. Ich hatte sie auf jeden Fall.
I hope you all had a fantastic lunch. I did have one, and I've got to make sure I'm back here with full power. But that's not a problem with the wonderful agenda we've got for you today on stage. There are different stages we're covering. We have covered so far at the innovation stage. A couple core subjects are AI. Everyone's talking about that. And at 2 o'clock today, right after the next presentation, we'll have our pop talk together with Sasha Loba. But there's a second very big subject we've been seeing all week is automation. And I think when you're in mass production, automation is a standard everyone wants to have. But then it gets exciting when you look at single part production. There you need a bit more. You need standardized processes and efficient preparation. And how to master these challenges? Well, we've got somebody to explain that to us today. So welcome with me, Tommy Kavala, Product Manager at tebis Communication Systems AG. Nice to have you here, Tomek. But before Tomek begins, let me tell you this. There are QR codes there. It's not just for polling or opinion surveys or asking how your lunch is. No, you can ask questions directly to the speaker, and after the presentation, it'll be my pleasure to ask them to you directly. Thank you. Over to you. Well, thank you. I gave this a lot of thought to how on Friday at 1:30 after lunch I'm going to make a presentation. And I thought maybe it's not too clever with software with a lot of colorful pictures and a lot of process charts and all sorts of diagrams, but maybe rather that's something a little easier to digest after lunch. And the subject we're going to talk about, automation, is not new. And now everyone was talking about Industry 4.0, advanced manufacturing, digitization, and the interconnectedness needed there. Automation is a part of that. Everyone is talking about it. Everyone tackles it differently. And in single part production, where we talk about one single part, there are completely different challenges. So once again, I'm not going to show you charts with all sorts of details and process flow charts and stuff, but I'll tell you a story that you see quite often. Why do we want to do this? The first question we have is, why? Well, it's quite obvious, really. It's not because of a shortage of skilled workers, not because of increasing costs, not because of global competition. Why do we want to automate? Because it's cool. We could do it. And there are some really cool machines here at the trade show. A lot of really cool machines that go back and forth automatically. Why don't we do it? And if we do it, why aren't we consistent enough in doing it? Well, very obviously, we've got some clear requirements, a demand. We're forced to do things here to cut costs, be attractive in the marketplace, and above all, increase my competitiveness. Of course, okay, I'm a geek. I'll do it because it's cool, it's fun. But as a company, it's actually mandatory nowadays, because the question is, are you going to do it? And if you're not going to do it, well, how can you afford to do it and survive? And then there are a lot of other things, too. After my presentation, there'll be a nice talk on AI, and everyone enjoys talking about AI in Germany. We're really open for new technologies. We don't think about data protection and who knows what all. We just throw everything into the cloud and step on the gas. But no, we do discuss a lot. We discuss automation, digitization, and the newest hype now is AI, hype or assistance. Now, the question is, okay, on the one hand, you're talking about AI, and then you put your thermal paper back in the fax because you're expecting important facts, or you write something on a piece of paper and you post it to the bulletin board. Now, this is the conflict here. We're talking about all of these things, and in all discussions about increasing efficiency, you hear the buzzword AI, but how can it help me? Now, if I don't have digital data today, or if digitization isn't done right, you're going to have trouble with automation. And the question is, how can AI help you to do anything if your processes are all manual. And then there's another important point, and that's why I'm making this presentation deliberately more general. We're all the same. Okay, some companies have small volume runs, some have mass production, some do tool making, some do die making, and different preconditions, infrastructure, machines, people, infrastructure, and there's a big difference here. Many differences. Let's take this one person, full of equipment, technology, and we see that symbolically here. You have a mountain climber with all of his climbing equipment, and ultimately he's just walking up the mountain to have a drink at the hut there. On the other hand, you've got people who maybe just get going. They say, I'll put on my flip-flops and climb up that steep rock face because I can do it. And in both cases, it's not appropriate. It might work out okay. There are examples where it might work okay, but basically these are the two areas we're talking about. And once again, we talk a lot about AI. You see a lot of examples at the trade show from actual practice. But if the basics aren't done right, it's going to be damn difficult. And now to stick to the idea of mountains and mountain climbing, let's talk about this. Without the camps, you have no peaks you can reach. There are speed climbers. They go up 8,000-meter mountains in 24 hours and back down. So as a rule, I can say we should talk about intermediate targets. And automation in single-part production, well, there are our intermediate camps that you first of all have to reach before you do anything else. Now, it's not about prioritizing things or a specific sequence, but it is a prerequisite you have to meet. These are quite simply processes, digitization, and the data. The data you've got to have stored somewhere. And there's another thing you must not forget. It's the human factor. You just saw the person smiling there, shaking hands with the robot. This is, of course, an important subject too, acceptance. Now, if you look at the processes, you see relatively frequently that things are kind of pieced together. Let's say you're going out for a trip in your boat, your inflated boat. Somebody brings something along, somebody brings a motor along, somebody brings this, somebody brings that, but one person isn't happy. That's the managing director. And there might be some tension somewhere. You might need predefined data. You're very well prepared. And the next steps, those are the bottlenecks. Those are the things that don't work. Or you might not even have the input parameters that people don't stick to it. So it's not me. So the process isn't a siloed solution. There are not individual solutions. We're eliminating the borders between departments because they cause trouble. They prevent things from happening. On the other hand, you've got your team going in one direction, and you've got to have a look at this holistically. All of the processes have to mesh, your workflow has to be completely transparent, and the data that you have has to be used end-to-end from the very first source to the final instance. And there are three factors here that you've got to get done right. These three areas, well, if you don't do them right, then automation will be just too complex, won't work. So we're talking about production environment, we're talking about machinery, you're talking about clamps and the setup concepts and everything to do with manufacturing. Then you've got, number two, knowledge production. Knowledge, methodology, strategy, and the know-how of your people, the know-how of company too. And last but not least, it is order handling. You can do good production planning for a bad process, but it'll remain a bad process. So you've got to know how to do these three things right and get away from departmental or siloed thinking and move toward a holistic concept from end to end, where your processes begin and where the workflow ends. And if you've got that, these three things, these three success factors, then you have to take another step. We've seen it. Another camp is digitization. And in manufacturing, we talk about digital twins. At tebis, we had digital twins long, long ago. It's been a few years, but you've got to do it, be able to do it. And when you get into manufacturing and you still have gaps in your information, in your data, in your knowledge, in your process, then you'll never succeed in successfully automating. You might have a nicely automated cell, and it'll have to be done the same way as you do with CNC machine. It's manual tools set up, manual intervention, and you won't succeed in getting that system up and running automatically. So here, what's very important is you've got to have the data on site, you've got to have the information on site, and once again, nothing can go wrong here, and digitization begins at the very beginning. So you have to stop writing things on post-it notes, you have to move away from siloed solutions, Excel, PowerPoint projects. If you look at all the projects, you see there's a wide variety. Some people might recognize what I'm talking about here. What's important is it's got to be end-to-end, and it's got to be usable to everyone at a central location. In particular, in manufacturing or production, where you have costs that might be double. You've got your people, and you've got expensive machines, and they're all there to help you make money. Data capture, and then order control, virtual planning. Nothing is worse than something unexpected happening. And if you talk about single part production, you can talk about a Pareto curve. 80% is perfect cycles, and 20% you have to go on to a secondary machine. And above all, you leave nothing up to chance. You've got simulated results on the machine. You enter them directly into the machine in order to prevent anything unexpected from happening, and having your know-how that you can use at a central location. Now, if you can do all of these things, you've given some thought to your workflow, your processes, you have a well-functioning, digitized environment, then and only then can you start talking about automation and coming up with concepts for automation. And of course, what's important now, how am I going to tackle it? What other factors do I need? As I just said, we won't succeed in doing it without people. We've got to integrate the people. We're not going to be able to replace people by AI, by processes, digitization, automation. Somewhere in there will always be people. And only if you do all of these three factors right, humans, processes, technology, then and only then can you successfully automate. These are the basic prerequisites you need to meet in order to automate in single part production. And here we have a big opportunity. You have to be courageous. A lot of companies have been trying it for years. 5 years ago, people were talking about Industry 4.0 and all of our challenges, opening up, networking horizontally. Now we can talk about Industry 5.0 because AI has been added. But what's fundamental is, okay, we could say maybe a bit provocatively, if you didn't succeed in doing it 6 years ago, why are you going to be able to do it now? So a rethink is necessary, and also people have to be courageous and just go and do things, and do them right, not just piece by piece. We saw what might happen if you did it piece by piece. That won't work out. An example of a couple things is what I'm showing you here. I deliberately don't want to show you flowcharts and stuff. I'm going to talk to you about people. You have salespeople, you have project managers, product portfolio managers. Every company is a little different, but I'm not going to show you a process map with value added and support process and so on. That's always cool, but not for quarter to 2 on Friday. So I'd like to give you a couple examples now, which can be automation killers, first of all, and secondly, what are the basic prerequisites here? And I want to say one thing. In terms of the system, we've got everything under control. If the system is the limit, then you've got other problems. The problem, that's the structure, the organizational processes, and the organization in the company. Let's look at sales. Sales has to ensure that what the customer wants is clearly documented. If you start by drawing up unrealistic quotes, because otherwise you won't get the contract, of course, so let's reduce the time, but then at some point in time your plans are going to fall apart, your production plans. What is that based on? Your calculated hours. Everything else is just going to be nonsense. And if you make unrealistic promises to customers and don't document them, well, at some point in time that's going to be noticed, and then there will be additional effort and expense required. And all of the information I don't have, the starting conditions, if that's not done right, I could say to the design engineer, okay, start your designing, and I'll tell you what we're designing later. It's like if I were to say, you go ahead, start traveling in your car, I'll call you in 2 hours and tell you where we're going. Now, you don't know whether that person has gone in the right direction, but you can still say they've done some performance. The salespeople might say, we have nothing to do with production, but you carry this problem from A to B, and the more time you need to solve that problem, the more time it's going to take at the end of the line. And then you've got the project manager. So if you do get the contract, then the project manager comes on board, and you have to consolidate all the information, the scheduling, the budget, the quality is what he's responsible for, the scope. Everything's got to be clear. All the information that's not clear now will cost time. The project leader will get that information, but it takes time. So if I've got the order, got the contract, and every project manager will do his own planning, his own Excel chart without looking at the other ones, well, it's going to be a problem if you have one project blocking the other. You might not achieve synergies too. Now, how are you going to prioritize things? Who's the customer? How much priority? What do we need? Here too, some processes might fail. So here too, you very clearly need a systematic, digital, global, binding plan, otherwise it won't work. Now, of course, in single part production, we don't talk about 100% certainty. That's clear. But you have to make everything as calculable as possible, and above all, recognize risks and bottlenecks early, because if you don't do that, then the designer will come in, and let's say you need a tool for 8 weeks. How long does a designer need? Well, 18 weeks. That's 18 weeks design. That can't be the delivery time. And he starts working, and he says, okay, he gets a call 3 hours later. He's supposed to go north, but actually he's gone south. He's wasted time. He's done something that's worthless. And of course, he's not too happy. Who would be? In design, another issue is this is where the digital twin begins. If you don't do your design with exact data that you can use later on, you'll have gaps between reality and the virtual environment, and you won't succeed in having a stable process. And another thing is, I'm familiar with this because I used to be a designer myself. It's a work of art. It's my work of art. It's got my signature on it. In the world of art, that's nice, but in our world of machine building, standardization and automation is necessary. You can't be original like an artist would be, so you have to have CAD data standardized, as much standardization as possible. Standards first in design, manufacturability. You have to take manufacturing into account. How is the setup done for the products? Do you need any special equipment in order to get that product running quickly and smoothly? And as I said, standards first. Then, when you're production planning, your work scheduling, people start thinking about it. Should we do it here or there, on that machine or this machine, or maybe we should farm it out? Well, I don't know. Then, at the very least, you've lost. Because that's the end of the line. You can do a cut. Because why? Somebody in the company's got to take something and move it from A to B. Now, we saw in design the same problem. People doing works of art, drawing up their own production plan without standardization, without classification of standard components and so on, then you will fail. And at the very latest, when you have drawings that you've printed, well, drawings are bad. There's no longer the job of technical drawing specialists. But if you print them out and then put highlighting marks on them and then put them up in the workshop, then I don't want to even hear anything about AI because that won't work. So here too, all of our orders must be completely digital and multi-project view. Not one project, all projects. We want synergies. Can I use different tools to bring together different orders so that you can define the right resource allocation, do your right planning, and above all, processes and standards have to be adhered to systematically. You can't say, oh, I'll do it maybe like this, maybe like that. There's got to be fixed principles. Then purchasing, procurement, yes, you do have that. Well, we're not sure about that. Are we going to do it ourselves, in-house, or farm it out? Well, I got it a little cheaper from the outside, but it didn't have the right one crucial part. You can do it, or you can get it cheaper from some other supplier, and you've got to adapt to what he's offering you. Now, of course, prices are important, but standard first is the key. You've got to keep to your standards as much as possible. So you have to have your parts, your external parts, as quickly as possible. You need information from your suppliers if you buy resources. And once again, standards, standards, standards. Then NC programmer, if he doesn't even know what machine he's supposed to do it on, then simulation won't work, and production planning won't work, and the whole process won't work. So a lot depends on this. Now, if I always use the automation, well, I have to do this right, and every step has to be taken into account in the core program. That is, go to the 0 point or the blank check or the finished product check or quality check in between there. Without end-to-end process in programming and in manufacturing, you won't be able to automate single parts for production. That was quick, too quick. So here too, templates, collision checking, and your objective is afterwards you just have to press start. Because the person who would be doing that actually has to do something else. More about that later on. Let's talk about the person pressing the button, but he doesn't do just that. Now, we talk about product designers. That used to be the person doing the drawing, and jobs change. There are some jobs that have died out, and there might be some new jobs in the future. My daughters will maybe do jobs that we're not even familiar with today, but you're moving away from machine operator to machine organizer. You must have no variance from standards, and if you start changing cycles and other data in your control, well, that's ruined things, because then you can't start automatically anymore. So you have to have startup programs one-to-one. Everything must be in there. The machine operator becomes the machine organizer. He's just going to monitor the process and definitely not improvise anymore. Then, last but not least, the person in assembly. Now, this has really nothing to do with manufacturing itself. Or let's put it this way. You've got 18 weeks delivery time for a tool. When will the assembly person begin? In the 19th or 20th week. So actually a little bit more even, because some parts were missing, or the ones I needed weren't there. I didn't have them. The ones I don't need, I do have. So then you go out, start driving, waste your time, costs go up, and ultimately you don't get what you wanted to get. So here too, the parts have to be made without planned reworking. I'm not talking about fixing processes and doing the functional parts. I'm talking about avoiding reworking, unplanned reworking 100% of the time. Make all parts available when you need them, transparently above all. And very important, knowledge. That's why I'm adding it last here. The knowledge here has to go back to the front end. All of the feedback of information, well, you've got lots of findings and knowledge, and if you start doing your conventional quality variance protocols and writing them down and putting them in a cabinet so that they can take them out 10 years later and shred them, well, then you haven't really established a self-learning process. Now, of course, I made all these pictures myself. I hope you can see that. One thing I noticed while I was doing these pictures, they're all smiling. Why are they smiling? Who would be smiling in our industry in all departments nowadays? People are often desperate. Instead, there's one thing that goes wrong and people are sad. The project manager is in despair. He doesn't know what to do. The salesperson has to set aside the configuration of the company car, and they've got to maybe call the customer and say some nice things. And then the managing director looks and he sees the reputation of the company is at stake, but we forgot one person in this chain. We wouldn't be here, none of us, if we didn't have that person. That's our customer. And if you can sleep well, when your customer looks like this and can just cry himself to sleep, then we've got an issue. Either you'll have a customer who loses out and they don't want to lose out, or you will lose the customer. And that's why we do all this. We do it because it's cool, but we do it in order to be competitive and enhance the profit of the company. And by saying this, I'm saying automation is not in a silo. We need defined roles in the process. We don't need organizational limits. We need a fixed design of roles, and we've got to adhere to them. And everyone assumes responsibility, makes a contribution to an automated process. And the mixture of process thinking, automation, and AI, and above all, humans, the human factor, that's what it's all about. It'll decide whether you're successful or not. And technology is only as good as the people using it. Now, if you look at motorcycle racing, they say it's not the bike, it's the driver. And that's what we're doing here. It's only as good as the people. Now, I did a bit of a different presentation. I didn't say what the company is, who I am, what we do, but I wanted to avoid that after lunch, even though it doesn't say tebis everywhere. We do have tebis in almost everything. You can come and see me afterward. Come and see me on stage at the booth, or you can see me, contact me online. Thank you, Tomasz, for that presentation. You mentioned one thing yourself, something I really like, is telling stories. And one thing I really liked about this, let's be frank, automation is a buzzword now. Everyone talks about it, but we often forget what is involved, all of the things involved with it. So your company does software, among other things. Your company is very strong in that. Now, there is a question. Automation. What is the status of automation today? Well, it's becoming more and more relevant, and any machine that's ordered anywhere for single part manufacturing does have automation. And there are some sad faces sometimes, because people say, okay, I invested a lot of money, but it's not really giving me the outcome that I was expecting. Then at the very latest, you have the issue of software, but what's much more important is you have to know the whole process and know the little levers you can change in order to tackle things and enhance the potential of an automated cell. Well, now it's a day and age of transformation for you. For years, there were proprietary systems, proprietary software. Intensive preparation was required, and now we heard about solutions on stage here where the robot itself learns where to pick and manipulate, and it's then just a question of time until the machine programs itself. So where are you right now? Well, we've got a really strong algorithm. We're working in AI. We do research. We've got study projects too that we're working on, and we're more stable, better with our algorithms than we were in the past. But this is the combination we've got to have. We have to have the knowledge and store it centrally for everyone, not just for the people who already know it, but people who perhaps aren't certain about it. You've got to cluster that knowledge so that you don't have access to just one area, but you have to have access to all parts of the decathlon, so to speak, information, software, AI, and it's got to be used so that at the end of the day you create value, and it's got to be digestible too. You just said, okay, that's a buzzword, automation, everyone wants to do it, but of course, we ask, why don't we do it? And this is the problem that we want to tackle. We want to say, do it this way. Start by doing this. That's an important point, because that's my invitation to our audience here. They should talk to you, ask you about the first steps. How can we tackle it together and develop it together with you? You don't just buy the solution at the end of the day. Thank you very much, Tomek Kavala, ladies and gentlemen. I'll let you go off the stage here. Let's give him a big hand, ladies and gentlemen.